Remember that the general power rule for integrals is that the integral of x to the n dx is 1 over n plus 1 times x to the n plus 1 power plus c. So a natural question is, what happens when n equals negative 1? What is the integral of 1 over x dx? Right, because we'd get a divide by 0 error. But remember that the derivative with respect to x of the natural log of x is 1 over x. And so the integral of 1 over x dx is the natural log of the absolute value of x plus c. Note we have to have the absolute value there because the natural log isn't defined for negative numbers. And more generally, the integral of du dx over u with respect to x is just the integral of 1 over u du, which is the natural log of the absolute value of u plus c. If all those symbols get really confusing, that's okay. What this means is that when you need to use u substitution in a natural logarithm integral, you always let u be the bottom part. So let me repeat that. Whenever you're doing integrals that involve logarithms, or integrals of 1 over something that turn into logarithms, and you need to do u substitution, you need to let u be the bottom part. With that in mind, let's look at some examples. The first and easiest example is the integral of 4 divided by x dx. So that's just going to be 4 times the integral of 1 over x dx, which is 4 natural log times the absolute value of x plus c. All right. Another example, the integral of 2 times x over x squared dx. There are 2 ways to go about this, and I'll show you both of them. First, what I find the easier way is we have an x on top here and an x on bottom here, and so those can cancel out. And we get the integral of 2 over x dx, which as we saw above, that'll become just 2 times the natural log of x plus c. The other way to try and solve this is to let u be the bottom part, be x squared, and then du equals 2x dx, and so we're left with the integral of 1 over x squared times 2x dx is just the integral of 1 over u times du, which is the natural log of the absolute value of u plus c. But remember, u is x squared, so that gives us the natural log of u squared, the absolute value of x squared plus c. And remember, these 2 answers are the same. 2 times the natural log of x is the same as the natural log of x squared. That's just one of the rules of logarithms. Let's look at another example here. The integral of 3 divided by 3x plus 1. So here we're going to have to use a u substitution because, look at it. All right, so we let u be the bottom part, 3x plus 1. So then du equals 3 dx. Well, isn't that handy? So our integral becomes 1 over u times 3 dx, which is 1 over u du. Don't forget the integral sign. And so when we take that integral, we get the natural log of the absolute value of u plus c. But remember, u is 3x plus 1, so we get the natural log of 3x plus 1 plus c. Let's take a look at this, the integral of 1 over 2x minus 1. So as always, we're going to let u be the bottom part. And when I say as always, I mean as always if the bottom part isn't raised to a power. If the bottom part is something squared or cubed or etc., then we can usually just use the power rule that we've used before. But in this example, where we would get a divide by 0 error if we tried to use our standard power rule, we let u be the bottom part. So we let u be 2x minus 1, so then du equals 2 dx, or another way to say that is dx equals du divided by 2. And so we can plug that in. We end up with the integral of 1 over u times 1/2 du, which is 1/2 times the integral of 1 over u du, which is 1/2 times the natural log of the absolute value of u plus c. But remember, u is 2x minus 1, so we have 1/2 times the natural log of 2x minus 1 plus some constant c. One more example. We have the integral of 6x divided by x squared plus 1. So we let u be the bottom part, and then du will be 2x dx, or another way to say that is dx equals du divided by 2x. So our integral becomes the integral of 1 over x squared plus 1 times 6x dx. We can rewrite that as 1 over u times 6x times, and remember dx is now du divided by 2x. So we get the integral of 1 over u times 3 du. But this constant 3, we can pull it out, and so we get 3 times the integral of 1 over u du, which is 3 natural log absolute value of u plus c. But u is x squared plus 1, so we get 3 times the natural log of the absolute value of x squared plus 1 plus a constant c. Now, u substitution, as we talked about before, isn't always a golden bullet that solves all of your problems. Sometimes it's helpful to rewrite the thing in the integral before we actually take the integral. See here, we have the integral of 3x squared plus 2x minus 1 over x squared. Now normally, if we try and let u be the bottom part, we'd end up with du equals 2x dx, but I mean, there's not enough to cancel there, and we're going to be left with a big mess. So before we try that, let's just rewrite the equation. So let's rewrite this to be the integral of 3x squared over x squared plus 2x over x squared minus 1 over x squared dx. Well, now we get some cancellation, which is nice. 3x squared over x squared is just 3 plus, and then 2x over x squared is just 2 over x minus 1 over x squared dx. And this is the same as the integral of 3 dx plus the integral of 2 over x dx minus the integral of 1 over x squared dx, which is 3x plus 2 times the natural log of x plus 1 over x plus some constant c. One more example. We have the integral of 1 divided by 1 plus e to the minus x dx. So here we definitely can't use u substitution because the derivative of the bottom part is like minus e to the minus x, but then we don't have any cancellation, and it's not going to work. And so we can rewrite the equation. So we have the integral of 1 over 1 plus e to the x is the same as the integral of 1 plus over 1 plus 1 over e to the x, right? That's what it means to be a negative exponent. And so that's just the same as the integral of 1 over, and now I'm getting a common denominator here on the bottom in combining. And so we get e to the x plus 1 over e to the x. And that should be in parentheses there. Now because we're dividing by a fraction, we flip and multiply. So we get the integral of e to the x over e to the x plus 1 dx. And now we can use u substitution. So we can say u equals e to the x plus 1, du equals e to the x dx. And so we get the integral of 1 over u times du, which is just the natural log of the absolute value of u plus c, which is the natural log of e to the x plus 1 plus c. And one more example here, the integral of x squared plus x plus 1 over x minus 1 dx. Again, I encourage you to try and use u substitution, but I'll save us all some time because that's going to end up not working out. What we have to do here is we have to implement polynomial division. And if you don't remember what that is, that's okay. I'll do a very quick run through. So x squared plus x plus 1 over x minus 1, well, that's literally just x squared plus x plus 1 divided by x minus 1. And when we're doing polynomial division, what we do is we look at the first term in both of these. So we have an x and an x squared, and we think to ourselves, What do I need to multiply x by in order to get x squared? Well, I have to multiply by x because x times x is x squared. And so now what we do is we subtract off this part here. We subtract off x minus 1 times this x. So x minus 1 times x is x squared minus x. And we're subtracting it off from this upper part here. X squared minus x squared, we get 0. X minus negative x, that gets us plus 2x. And then 1 minus 0, because you can think of like plus 0 here. 1 minus 0 is just 1. So we end up with 2x plus 1. Now what do we need to multiply x by in order to get 2x? Well, we have to multiply it by a positive 2. And so now we subtract off 2 times x minus 1. So we have 2 times x is 2x. 2 minus 1 is negative 2. 2x plus 1 minus 2x minus 2. Well, 2x minus 2x is 0. And then 1 minus negative 2x. We have 1 minus negative 2x. That's going to get us positive 3. What do we need to multiply x by in order to get negative 3? Well, I mean, there's no copies of x here, so we don't really know what we'd have to multiply x by, especially because x is a variable. So that just means we have a remainder. So we have a remainder of 3 divided by x minus 1. So that means that this integral here, this integral of x squared plus x plus 1 over x minus 1 dx, is the same as the integral of x plus 2 plus 3 over x minus 1 dx. And so that gets us 1/2 x squared plus 2x plus 3 times the natural log of the absolute value of x minus 1 plus a constant c.